In this problem, we are given a formula s of t equals 16t squared. That formula is used to approximate the distance s in feet that an object falls freely from rest in t seconds. The problem states that the height of a building is 1,217 foot tall. The question is, how long would it take for an object to fall from the top of the building? So the idea is this: you have your building in the ground. Okay, you're dropping an object from the top of the building, and the building is 1,217 foot tall. This formula represents how far the object falls. So the actual distance is represented by the s of t equals 16t squared, where t is in seconds. So to set this problem up, we're saying that we want the distance s of t to equal the 1,217 foot, since we want it to fall all the way to the ground. So the equation that we want to use to set this up would be 1,217 equals 16t squared. We see that this is a quadratic equation because it has one variable and the highest power on the variable is squared. To solve a quadratic equation, in general, we need 0 on one side. So what I'll do is I'll take the 1217 and I'll move it to the right hand side by subtracting it. So I'll have 0 equals, and then over on this side I want everything in descending order, so I'll put the squared term first and then the minus 1217. There's several different ways to solve. On this particular example, I'm actually going to use my graphing calculator. Here I want to enter that equation into y1. So go to the y equals menu. If you have anything in there, clear it out. And then enter 16. Instead of using t, we know we need to use x. Then raise to the second, right over, and then minus 1217. Now, in order for this to show up on our graph, we know we need to set a window that would include the negative 1217 as our y-intercept. So let's go to our window. Okay, also think that in this case our t value, which is x in our calculator, is time. We don't want to use negative time, so let's start our time at 0. We don't know how far we want the time to go, so I'm going to leave that at 10 for right now. We can change that later. And then go down, and we want the y minimum to be at least this value. What I'm actually going to do is set it at negative 1,300, and we'll see if that works. Alright, and then I'm going to leave, just for right now, the y max at 10. Let's go graph and see if we need to make any adjustments. Okay, we see that we have our y-intercept, that's good, and we see up here our graph going up towards our x-axis. We can see that we can't see our x-axis very well, and in our problem the 0 is representing our x-axis, and we specifically want to know where does it cross the x-axis. And so probably for this we want to make our x value, or I'm sorry, our positive y values larger so that we can physically see this x-axis. So go back to your window and let's make it even. So like we've used negative 1,300 as our y minimum, let's make our y maximum the same value but positive. So let's use 1,300 here as well, and that will at least make our graph look symmetric. Alright, that looks great. And we also see that the value that we want to find is shown within our graph. Alright, let's sketch that, and then I'll show you how I'd want your labeling. So you've got something that looks like this. Okay, and that's our function s of t. Alright, what values did we use? We used, I believe, positive 10 here. We used 0 on the x-axis as the start, so we can actually come back here and get rid of most of that. And then we used 1,300 above, and then down here this was negative 1300. So just label those particular values. The horizontal axis would be the time axis, the t-axis, and then s of t would be the y-axis. That's the height. We want to find this point. We want to find when this object hits the ground. Hitting the ground would signify that our distance needs to be 0 units from the ground. And so that's going to be where I cross the x-axis. To do this, do second calculate. Go down to option number 2, which is 0. It's asking for a left bound. Well, this is what we're interested in, so let's go a little bit over there closer to that value. Okay, right around here, I'm just a little bit to the left of what I want to find, so press enter. And then when it asks for a right bound, make sure you go over and across your 0. Somewhere in here would be fine as the right bound. Press enter, and then when it asks for guess, press enter again. Alright, this particular problem, I believe it didn't signify or denote what to round to. Let's say we want to round to 3 decimal places. And so here our 0 would be 8.721, comma 0 for that ordered pair. Okay, the question asked, how long is it going to take for the object to fall from the top of the building and then hit the ground? So in this case, you would say the time would be 8.721 seconds. Be sure to put your units, and then you're done.